Juan, and welcome to another episode of Graph Builders Office Hours. Today is a really cool, small little tool that we're going to be hopping into that should help the Subgraph developers out there. But before we get into the tool, of course, this is Builders Office Hours. We do bring on builders, and I want to introduce the builder of this little tool, Juan Defago. Did I say that right?
Yeah, exactly. That's
Okay,
great.
awesome. Juan Defago. I'm just going to stick with Juan, so I just
Yeah,
say,
I
say
mean everyone knows me as one, so it's fine.
yes. It's Juan. So yes, welcome to Builders Office Hours, Juan. And how are you doing today? If you could just go ahead and introduce yourself. Also, how's it going?
Yeah, I mean it's been going great. Again, as we spoke, like it's the beginning of the year. It's always past the holidays. Uh, it is a weird time. January vibes. Half of the team is usually off. Half of the team is here. So, but it's been great. It's been refreshing holidays, and a lot of work coming ahead. So yeah.
Yeah, you've been in GraphOps and the Graph ecosystem for how long now?
It's been quite a long time. Yeah, I started working in the graphical system, not under GraphOps, but under other companies. Early 2020, I think even January 2020, I would say. So it was before the network launched.
That was
So
literally the same month I became aware of the graph. I remember this. That
it
was
was also the same month that I became aware of the graph. Like that's how it works.
yeah, I remember I was working as a physical therapist. I'd been coding Python, building Raspberry Pi scripts and having fun for years, just tinkering. Pandemic hit and I couldn't go into clinic anymore. And I remember just diving into crypto. And I was like, this is the new technology of the future. What do I have to know? And the graph was literally one of the first protocols I found.
Yeah, I mean, again, like my story with crypto was I wasn't a physical therapist. I was a developer before. I had been working for like 3+ years, in a kind of like a dev shop sort of
Mhm.
company.
Yeah.
And I kind of like decided, okay, I'm just gonna, try something new. And then I started in this company called Protofire. Probably
Mm.
some of the developers here might know them. I think
Mm.
they're still running an indexer or something. Um, and they kind of like initially I was just gonna be kind of like a front end developer with a little bit of interactions for Web3, so just consuming some Web3 data. But when I joined, they said like, oh, you know what? Like we're working with this new company now called the Graph, and we want you to start specializing in subgraphs. Like that. That
Mm.
was kind of like, and I was like, what even is a subgraph, right? Like, what am I getting into? Sure, like
I
let's
what
play
is a
around.
subgraph? That's essentially the first. I remember I was deploying subgraphs before I knew what they were. That was shout out to the UI UX team, the website and how easy they made it to deploy. I remember like what the heck is a subgraph? I'll deploy one. Oh, okay. What's GraphQL? Okay, like literally very interesting to find subgraphs as a whole new concept.
Yeah, I mean, like when I started again in the crypto ecosystem, again, I started with the graph. Like I remember when I was preparing for that job. Again, it was not gonna be, I wasn't gonna be a subgraph developer. It was just gonna be a front end that consumes from Web3. So I was kind of like starting to look at Web3 as to what even is Web3. I was just a Web2 developer like any other back in that day. And I was like, okay, like how do I even consume Web3 data, right? Like how's the, and I kind of like started digging into how Web3 works, how the blockchain works, how like all of the different tools. And I remember back in that day, while I was preparing like in late 2019,
Mm,
like there were things like the kind of like the coolest skill in the blood was things like truffle, so that you can play around with
right,
blockchain data locally to play around a
right,
little bit and get a little bit of experience.
right.
Ganache didn't even exist back then, which
Mm.
again Ganache now is kind of like really old school. Like truffle was even more old school.
What are
Um,
people using besides Ganache and Truffle now? Those are my
Hard
two.
hat, hard hat
Oh yeah,
maybe, I don't know,
of
like
course.
Foundry maybe.
Anvil with Foundry. Hard Hat has its own. Yeah, yeah, yeah. Okay, of
Exactly,
course.
yeah. Like
Yeah.
again, all of those things in the contracts land, so to speak.
Right.
And I was kind of like trying to get into a little bit of Web3 knowledge, because I literally knew nothing about Web3.
Mm.
And then like I was kind of like thrown into this whole new paradigm of, hey, you know nothing about Web3? Well, you can. Do you know about GraphQL? Yes, yes, for sure. Like I am a front end developer. Also, I kind of like new backend. I studied at university, so I had a little bit more of a base to work with.
Mm,
So I started playing around, and then suddenly, like I met some of you might know him, Martin Telechea,
mm. Yep.
from he was working in the Graph Foundation, but before that he was actually part of the Graph, which was
Mm,
kind of like the company.
mm,
Um, and then I started working with him very closely. He kind of like mentored me into what subgraphs were,
mm.
and I started just developing subgraph left and right. Like mainly back in the day, it wasn't even the network subgraph because that didn't exist.
Right.
It was
Right.
mostly just kickstarting subgraphs for different protocols like Augur, like
Mm,
Kyver, again, the Compound, like all of these protocols that I think Compound's still around, but like all of the others, I
mm.
don't know where they are currently. Like I feel old now that I'm saying this out loud, but
Right. Right.
um, yeah, I mean it was great. Like later, I when the graph was working on the network, they kind of like approached me and said, hey, we have this group of people that's working on the network. We need someone to be able to take care of the development and the maintenance of the network subgraph, which is something that we're going to be needing to work a lot on. And from that point onwards, I kind of like always been the go-to guy for network subgraph related questions
Mhm.
and issues, of course, like many issues over the years. Like, um,
Yeah, and
yeah,
you've
as
been
you know, it's been
around
great.
long enough. I mean, I've seen some of the subgraphs that you've been working with. There's some big subgraphs that I've seen
There's
with your
some big subgraphs. There's some weird subgraphs.
yes, there. I'm a fan of going through GitHub and seeing where you've been working on some of these subgraphs and saying, "Oh, okay, there's a Juan subgraph. That's going to be a big one.
Yeah,
That's gonna
usually
be
if you see that I've been involved, like expect weird stuff to be there. I remember like one of the, I'm actually pretty proud of that subgraph, but it is quite weird. Is the we have the EVO subgraph, which like the whole EVO, the Epoch Block Oracle, for those that don't know what it stands for, um, was a crazy project to be as gas efficient as possible on L1.
Mm,
I think Zach came with the idea of how that should work, and it has a lot of it's some specific encoding and decoding properties that we came up for just for gas efficiency. It was really weird. Like now, if you want to add stuff to it, it's a little bit over engineered. But
mm,
then you also have the loop ring subgraph I made back in the day, which was really weird because like the loop ring protocol, for those of you that don't know, was an L2, still is, I think, an L2 when L2s were still a new thing.
mm,
That was mainly focused on trading, swapping, whatever,
mm.
and it kind of like offloaded all of the data as an encoded packet onto L1, so you
Ooh,
could actually just rebuild the whole
sure.
transactions that went through on L2 without having to actually have an L2 RPC. You could just look at the L1 transactions and rebuild them. That required us to build the decoding algorithm
I was
for
about to
the
say, yeah.
exactly all of the decoding algorithm is written in assembly script for a subgraph,
There you
so it
go.
is written in subgraph land just by taking the bytes and doing weird
Yeah.
decoding stuff.
Yeah.
So it was pretty fun, pretty crazy stuff. Not what most people would do on a subgraph, like not what
Sure.
subgraphs have been mostly targeted for,
Hmm.
but it's cool that it's still a possibility to do those crazy experiments and to make them work.
Yeah, I've seen a lot of experimentation with subgraphs. I think their PMF, their product market fit, their launch, their real integration deep within Web3 and crypto essentially a part of the architecture from the beginning, from DeFi summer, from early on, and then seeing how many engineers did things. I mean, right now, Graph Node, the amount of features in Graph Node comparatively to where it was in 2020 is crazy. Like the
Oh yeah,
amount
like
of
yeah, I
features.
don't even know. I don't even know some of the latest features that there are still, like
Yeah, yeah. They're really impressed. I'm really impressed with Graph Node team and the Subgraph team just still pushing new features and new ergonomic changes that allow essentially, I mean, it one thing I love, and also this is, once you start working with subgraphs for long enough, you start to realize their limitations. They're wonderful if you want exactly what they provide you.
Yeah, yeah,
The-
yeah, yeah.
and and to be fair, it covers so many use cases for what it can do, and it's a really good generalist. It's so good at doing that. And I remember learning that and learning about essentially competitive architecture that could provide similar things to what subgraphs can do, and understanding the flexibility, the malleability, wonderful with all these other tools. But if you want a singular tool to do generalist work across the board, you can't really do much better than a subgraph. And it keeps on having new features added, such as, I think it's a good tangent, or a good, not a tangent, but bridge to talk about what you've been working on, Juan. So yeah, what exactly is this tool that you've been working on specific for subgraphs?
Yeah, for sure. And just to comment on what you were saying, like, yes, subgraphs are, I think, for indexing data and for exposing data for the blockchain, I think it's the most Web2 friendly that there is. Of course,
Yep.
it has some, trade-offs. Like, it can't be, the silver bullet for everything. It can be the most performant while at the same time being the most flexible. But it's still, quite a decent architecture. So it is.
I mean, for
I
most
think
use cases that I talk to that are out there, it fits wonderfully.
it
And
fits
that's
wonderfully. Yeah, for
it
sure.
fits wonderfully. It's if you have a blockchain event, there's not really more simple ways to access that event and index that event and potentially transform that event than a subgraph.
Yeah, particularly enriching the data. Like, that's
Yep.
what I've been working for the most time while I was working on subgraphs. Making sure that the data is not just the contract data. You can get the
Mhm.
contract data for just an RPC. You don't
Mhm.
need that. You need more thorough, enriched data to be able to
Mhm.
do front end with. That is how it is.
That
There
is how
is
it
no
is.
workaround.
It,
So
I say if you want a
yeah,
database experience with crypto, you should probably go to a subgraph.
yeah,
Yeah.
yeah. So
Yeah.
yeah, like, one of the things that, particularly for me, it was always lacking. And I would say, particularly since I got used to the Rust ecosystem, like,
Mm.
this tool that I've been working on. Uh, I don't like. Initially, I wanted to prefix it with the word basic, because for me
Mm.
it's not, as complete as I would always want it. I'm a little bit of a perfectionist, so nothing's ever gonna be enough.
Of
But
course.
I was told by people that know a lot more than I do in marketing that, prefixing something with the word basic is usually not a good idea.
Yeah.
Um, so
Yes.
so
And
I was
I think
convinced that.
what I've
Yeah,
learned also in being DevRel is once perfect is achieved, it's not as interesting.
exactly. Yes. So, uh,
And if you're releasing something that is, the bike wheel metaphor, don't build an entire bike, you build one little part of it, and then you can build around it. So, yes, don't feel too
exactly.
bad if it's not perfect. We're telling your story.
Yeah. So I was working with the Rust ecosystem after working for Subgraphs, with Subgraphs for many years. I kind of like start playing around with Rust, albeit, like, the use cases that we have for Rust. Sometimes in GraphOps, we were a little bit too Rust, enthusiastic. So we
Mm,
use Rust even for front ends,
mm.
which is not what most people would do. We when we build graphs here, for example, we
How
use
do
Rust
you?
for the front end.
I
Yes.
mean,
How do you
right?
exactly?
Like I immediately went to state management, and I was like,
I
"What?"
mean,
Like I understood. Like that's
it is
really
weird.
interesting.
You have tools like Udux, which is kind of like Redux, but for U, which is the front end framework that we use for Rust. Essentially,
And
it is
does it? I
messy,
mean, I'm
as you would
already thinking
expect.
of Dom. Okay, go ahead. Go ahead. Sorry.
It is messy. It is
I did
messy,
not
but
know that it even could do that because I've
it
always
is
looked at it
possible.
as.
Like, graphs here, even though it's outdated now, we haven't been able to update it for Horizon yet.
Sure,
A small team, we don't have a lot of bandwidth. We have to prioritize what we work on.
sure.
But graphs here works. It's
Okay,
completely built in Rust. Like,
it's
100% of
completely.
graphs here is built in Rust. I think it uses some bind gens for JavaScript things that are not built in Rust yet. But aside from that, the code that we worked on is all Rust. So while I
Mm,
was working with Rust, I realized, like, hey, the Rust compiler is really, really good at letting you know if you have any issues with your code. Like, it is one of the most amazing things of actually building stuff in Rust. Aside from, you have a lot of givens that you don't have to play around with memory as much as C++.
Sure.
You have a lot of good things, but the compiler for me, coming from 4+ years of building subgraphs with assembly script, and as many
Sure.
as you know, if you've ever built a subgraph with assembly script is weird, man. Like it has,
Yeah,
yeah,
it wants to be TypeScript. Like well, I mean, it looks like it, and then it doesn't. It's strictly typed. It does compiler does not give you good information.
yeah,
It's if assembly script had a better compiler, that would be very nice. That would be much more ergonomic. Yeah, I've been tinkering around with Rust these last, I'd say 6, 9 months, and every single time I see the compiler, it's a dream. It's like, cool, this is
yeah.
exactly what's going on. This is what you need to do to change it. Thank you so much. Let's move forward. There's
At
nothing like that.
first with Rust, like what most people don't get, or what it even happened to me, like what I got really pissed at is like I wanted to compile something to just try it out, and
Sure.
it throws you like 1,000 errors, and you say,
Yep.
why do I have, like, you could figure this out by yourself, right? Like,
Yeah.
yes,
Yeah.
but you need to do things correctly, and if you do
Hmm.
things correctly, it will work, and it will not blow up randomly in the middle of the night, and it will not wake you up by an emergency call and break a video or whatever.
Yeah.
um, and that all of those things for engineers, for developers, that matters.
Hmm.
And when I kind of like got past the first month of just hating the Rust compiler, I started to kind of fell in love with
Yep.
the amount of detail that it could give you onto, hey, you're doing this, you probably meant to do this, even
Right.
in really weird things like when you need to do distributed systems and whatnot, and you need to get blocks, other things like a
Hmm.
bunch of things that are really low level. um,
Sure.
and in those cases, it even helps you in those cases that are extremely weird. So I said, okay, why don't we have something like this for subgraphs? Like, of
Right.
course, again, the Rust is another language that is a lot more robust than assembly script. Assembly script kind of like tries to bridge a gap between having things be WASM,
Hmm.
so that they can be executed in GraphNode efficiently, but also allowing you to code it as if it's TypeScript. So there is kind of like a mismatch there of how
Hmm.
things actually work behind the scenes. So I get that that the compiler might not be as great. Okay,
Hmm.
great, but I know as an engineer that we can just look at the code and try to figure things out. Like there are some things whenever you build a lot of with subgraphs, you start to realize like there are many patterns that are not ideal.
Yeah.
There are many patterns that we use all of the time, and there are many patterns that we know that the compiler or even the graph build command cannot really figure out that are wrong. And
Yeah, and well, one of those things that sorry to interrupt here,
yeah,
but
yeah,
like one of those things that I love about this linter, I played with it, and a lot of the things I'm educating, and I have been for years, in terms of documentation, videos, updates, is letting people know about graph node features. The problem is, people might not be looking at change logs every other week. They might not be seeing the release notes. They might not be seeing
I'm
the stuff on
guilty of
Twitter.
all of those things.
Yeah, oh, everyone is. Like, no, we're too busy, and that's totally fair. And I feel like this next iteration of ergonomic dev tooling ingests what the engineers are doing and processes it similar to almost like a real-time MCP, but locally for exactly what that engineer is doing and lints exactly what you're doing. I feel like we're getting to that cusp where
Yeah.
updates in engineering are getting closer and closer, where informing engineers of new techniques such as, I saw on your subgraph linter there is the ability to see if there's ETH calls being declared or not. And I can't tell you how many times I've talked with engineers about, hey, do you know about this? And like, no, we've been doing ETH calls forever. And these are little things that make a huge difference
Exactly.
in communicating effectively through the lowest common denominator, through the actual code editor. That's the holy grail for me in terms of educating developers. Are you there? Did I lose you? You're muted. If you're talking there, Juan. Oh, hopefully I didn't lose you. Oh no. Unless my speakers are gone. Juan, are you there, buddy? Oh, is anyone in chat? Can y'all still hear me? Or am I gone? Let's see. Juan, are you there, buddy? I'm unmuting you. We're having such a good talk. Oh no, I know. We're having such a good talk. Okay, so it seems like he disconnected. Let me check to see messages. Oh, I see he has messaged me. The internet went down and he is reconnecting right now. So, yes, we were just chatting essentially about getting to that lowest level of the developer experience where the amount of features that are coming out are, really interesting. And the ability of being able to lint is quite low level in terms of the developer experience, seeing if something will actually compile properly. That is really nice. So, for the time being, I actually have this pulled up. And oh, perfect. You're joining right back in. Hey,
Yeah,
buddy.
sorry about that. My internet well, I actually not my internet, my whole power. Thankfully, I have a laptop, but my power just went down. So I'm now with one single monitor and my
Oh,
laptop.
no. Oh,
Yeah,
man.
hopefully
Okay.
everything goes decently.
Yeah, well, you're saying this, and I was literally just about to bring up the linter to demo it for the sake of just having the audience see. Would you be able to demo right now with your
Yeah,
setup?
I mean it's gonna be a little bit more uncomfortable, but I can do it. Don't worry.
Okay,
I'll
cool.
actually just go ahead with the slideshow first.
Sure,
Let
go ahead,
me.
and I'll actually turn off
Yeah,
my screen just to save on your internet. Is that fair for right
I
now?
think it should be okay. Like 5G
Okay.
can take
Okay.
a little bit
Well,
of
if
internet.
there's anything happening, let me know. Okay.
Yeah, sure. Let's. I'm gonna share my screen real quick.
Sure.
Um, Entire screen. There we go. Or actually, let's go with this one. Okay. Can you see the screen?
It's loading. Yes. Subgraph linter, graph ops, static code
Great.
analysis. There we go.
That is exactly what I wanted to show.
Okay.
Um, and as long as you can keep, because I don't have the mute button anymore, because I only have one screen now. But as you can see, and as we've been discussing, like I've been inspired by the Rust compiler, so I wanted to build something, as I mentioned before, that kind of like works like the Rust compiler, and I even like took some inspiration in how it works in CLI mode. We will be discussing about this in a little bit, but um, to get into the linter a little bit more, I wanted to discuss the linter in three different levels: the why, the what, and the how. Of course, I am a developer, so I probably should have added more um, uh, kind of like comments on these slides, but they're gonna be rough, but they will be useful. I promise. Starting with the why we built the subgraph linter. We kind of like already discussed this a little bit, but um, there are many times where you're developing a subgraph and you get to the stage where the compiler errors are fixed. Like the most egregious errors, like oh you forgot that you didn't declare this variable, or you forgot that you don't have this in the parameters. The usual stuff. All of those things are fixed, and it builds successfully, and you say, great, I am a great developer, I'm just gonna be deploying it, and everything's gonna be okay. That would oftentimes be a rookie mistake, because most of the issues that we detect, at least in the 4+ years that I've been working in subgraphs, most of the issues that I get are usually just only detectable once I start running and I deploy and I start running my subgraph somewhere, be it locally, be it in the I'm gonna feel really old with this, but in the hosted service, or now in
That
studio.
that's not
Uh,
super old. That was literally, it feels like a few weeks ago, so don't feel too bad.
for me it was yesterday. It still exists, but
Yeah.
yeah, when I deploy to studio, I still think that I'm deploying to hosted service. You know old people stuff, but usually I kind of like deployed something and then I realized that it instantly crashed because I forgot to maybe just initialize a required field in a particular entity, um, which was always like, oh my god, I wasted like 5 minutes deploying, making sure that it starts picking it up. I wasted resources because people had to start, in the case of hosted service, the hosted service has to pick up that subgraph, has to start processing it, and it crashes instantly because I forgot to initialize a variable. Like something as simple as that. Or maybe I forgot that something can be null, and I didn't check for if it was null or not before trying to access it. All of those um, issues are, only, at least so far, only been able to be detected during indexing, or whether you're really a perfectionist and you go line by line making sure that nothing can go wrong.
Right.
Sometimes you edit like 2,000 lines and you can forget things. Like, we
It's
are
just a
not
different part of the
LLMs.
brain. It's a different part of the
Exactly.
brain to actually
Exactly.
engineer creatively and come up with solutions and then go through essentially syntax and just make
Exactly.
sure all of that detail is dialed in. It's a completely different part of thinking. So I understand this pain. I do remember many times the null checks not really I wasn't the best at those. So I remember that many times. Yes.
Yeah, I like the amount of times that something broke because an unexpected null error. Yeah, I'm gonna go bald if I keep getting
That's what
yanking
happened.
my
That's
hair.
what happened with me.
Yeah,
This I
exactly. It
that's
happens. It happens to everyone.
this is a
Um,
subgraph hairline right here.
exactly. So again, those failures are expensive. Like, in many different ways, they are expensive because they're expensive. Sometimes it takes a lot of time to detect. Like, some of those errors might not result in crashes. They might result, like some of the things that we check for in the linter, might not result in crashes. Might result in actual bad data being served because you have committed a mistake. You maybe had some entity overrides happening in your code that are not really something that's going to crash your subgraph, but it's something that's going to lead to a lot of bad data. But if it is something that crashes, it might not be something that crashes instantly. It only crashes under certain edge cases. And once you get to those, like maybe you crash the whole network because the network subgraph crashed at 1 a.m. and you're sleeping, and you have to wake up, figure out what's happening, resync it. Resyncing that subgraph might take a day, and if it takes a day, you have to figure out if you can graft it. So again, it's a lot of engineering time. It's a lot of downtime that you can have because of those issues. There are hot fixes that might be required that then have to be replaced with actual full fixes for those issues. A lot of time that's lost just because we couldn't make sure that this worked before and ahead of time. And most of these issues, I don't want to say most, but at least some of those issues, I got I got them over and over and over across many different subgraphs across multiple years. So I kind of like got a sense of what those errors usually are, right? And I kind of like made a brief list here of those patterns, and they repeat across many different subgraphs. So that's why we built the subgraph linter, because we had those issues and we kind of like got tired of having to deal with those, and we wanted to make something that was gonna be helpful, right? Now we're gonna go to the what. What is the subgraph linter, right? Like, there we go. As I mentioned previously, it is a static code analysis tool for subgraphs. That means, as all of the developers know, it just means that it statically analyzes your code. That's all that it does. Like, it doesn't need anything else. It doesn't need to run your code. It just needs to look at your code, make sure that some things are as the code supposedly mentions, and that's pretty much all that it needs to do to run. What it actually does is it analyzes the manifest and the mappings, it checks for common problematic patterns, and it then returns some useful diagnostics. Kind of like the second line is a little bit as to why we built it, to improving developer experience, but we also made it as a configurable and extendable, easily configurable and extendable tool. And we also wanted it to be, initially it was a CLI, but we also wanted it to be something that's much more reactive to the developer workflow, right? I'm gonna pause here in case there's any questions.
Oh, I was muted. Sorry. Not seeing any questions right now in the chat.
Great.
But yeah, keep
I
on
was a
going.
little bit worried that I had lost my connection, so I
No,
went
no,
to
that
pause
was
to make
me. I
sure.
was
Yeah,
talking and I didn't see the mute was on. Go ahead.
yeah, no worries. So, having said all of this, having said what it is, we get to the how, which I think for builders is going to be the most interesting one. Like, okay, yes, it's a static analysis tool. great. It's useful. It works. We'll see it later in a demo. But how does the subgraph linter work? For those of you that played around with subgraphs, the essential details. This is a high level. Of course, we're not gonna go into the code on how it works. Line by line. But on a high level, you can think of the subgraph linter, loop as 3 or 4 steps. The first one is it will analyze your manifest. By default, it tries to figure out if you have a subgraph.yaml file, which is the common standard for the manifest file. It will go through all of your manifest, trying to look for relevant information. That includes things like all of the handlers that you have available, because it will need to go through those handlers later. What the files where those handlers are defined are, what is the schema looking like, and it will also, and this has to do with a particular check that we have, it will also try to figure out if your handlers have ETH calls declared, and it will process them and keep them in a separate structure, because eventually we will need that for some of the checks. After that, it will try to validate that each of the files referenced by the manifest, so all of those files where you have your mappings, your schema, everything, is included in the project. That means in your folder. It will normally use the tsconfig.json file to figure out if there are scope issues or there's some files missing. If not, it will kind of default to the default tsconfig. And that's kind of like the first step, kind of like just analyzing the quote unquote metadata for your project and figuring out if everything is in the place where it needs to be to actually do the things that we are interested in. After that, it will run the checks over the handlers that it found in the manifest. So let's say you have a manifest where you have handle transfer. It will run all of the checks that are defined, and we will get a little bit more into detail on that. All of the checks that are defined with each of the different severity flags, and check through using the an AST structure to find any problematic patterns. How does it do that? It will essentially walk through the AST for the handler, figure out if, for example, I'm just gonna get one random check. Like if you have an entity override check with the entity override, the thing that it checks for is whether you loaded an entity, modified that entity, and before saving that entity, you loaded the same entity with the same ID somewhere else in the code, like maybe in a helper or maybe somewhere else. You also modified it, and then you saved it, and then you saved the same entity that you had on the higher level scope, right? So essentially that stems from an issue that I was having, where I was loading and updating entities within handlers, and I was also doing that at the top level scope. So some of those updates that I was doing in the helpers were not going through, and it was missing some values here and there because the top level loaded entity, which had the same ID, was overwriting all of those results, because they were essentially just two different instances of the entity that were overriding one and the other. So it will look if you loaded an entity, which ID you used to load it, and then it will look if you loaded it somewhere else within that scope, see if you saved it, see if you had some issues, some values that were overridden, and it will let you know, hey, if you do this, you're going to overwrite your entity. And essentially, again, it just walks through the AST, tries to find those problematic nodes, and it will let you know with returning issue. Of course, this is not the only check. We have unexpected node checks, unexpected load or non-null loads that are forced with the non-null operator, as well as many others. We will go through the list once we're playing around with the demo. But essentially, all of those checks are just polymorphic modules that have an ID and a description, and also the run context function, which will allow you to do anything that you want with the AST. So it will allow you to go through the AST. The AST is essentially just a tree structure that has all of the function calls, variables, like everything that's on the handler as a tree structure, so that you can traverse it, figure out which comes first, what things happen within the handler, and having all of that structured in that tree format allows you to find problems and patterns quite easily. And again, it's a polymorphic module with all of those things, and it will essentially just get the context and return all of the issues. The reason why we built it in a polymorphic way is because we wanted to make sure that it is easily extendable. So if we want to add another check, we just need to make sure that that check can be processed with the context, which is essentially the AST that we generate from the code. We generated with a package called tsmorph, which generates AST from TypeScript code. In this case, AssemblyScript and TypeScript are essentially the same. And after getting all of those list of issues, we just do some post-processing. And again, this post-processing step has been mostly just so that the user experience is a little bit better. We added something that's called severity overrides. Essentially, this allows you to flag if you want a particular check to be a warning or an error, and that's particularly important if you use it as a CLI. If you use it as a VS Code extension, it's just essentially whether it's gonna be a red dot or a yellow dot, so a warning or an error. But in the case of the CLI, errors will return non-zero codes when it finishes processing, and warnings will return everything's okay code, so zero code. So that can be also used within a CI, continuous integration, continuous deployment pipeline. So as a CLI, it works for continuous integration. As a VS Code extension, it works more on like a normal or common developer workfloll. And after the post processing,
I installed it as essentially just as a self-running repo on my machine. Didn't understand install it as an extension. How are you using it day to day? Since you're the one who built it, what's your preferred workflow?
It depends. Mostly I use it just as a VS Code extension. Again, it is available in the marketplace, so if you want to upload it, you just need to search for it. And I mostly use it just to let me know, hey, there's issues for this. But this is a brand new tool, so I haven't yet, got the time to actually put it into a CI/CD workflow. We would also need to package it for NPM so that it's easier to use for continuous integration. But regardless of that, eventually I would kind of like want to have it as a step in pull request, like automatic step or action for pull request, so that it checks, it runs all of the tests, and it also runs the subgraph linter to make sure that everything's okay before we move ahead and do anything. Of course, depending on the project, you might want to check, change the severity overrides to maybe you care mostly about the subgraph linter just letting you know there's an error only if there's things that are super critical, like for example potential divisions by zero or unexpected nulls. But maybe you don't want to crash because you didn't declare an if call, because for whatever reason, maybe
just a warning on that one. Yeah,
just a warning on that one, because in the network subgraph, for example, we did, once we built this tool, we didn't, like initially this tool didn't have the if call checks. And David Lutter was telling me, hey, you should probably declare if calls. So I said, okay, let's add that check for the subgraph linter, and let's see if we can make it be easier to do that. We actually went ahead and refactored the whole subgraph to use if calls, and we realized, yes, we use a lot of if calls, but it's only once per handler, so we don't really gain anything by declaring the if calls, because it's just gonna run one if call in parallel, which is just one if call. So it's essentially almost the same thing as not declaring them. So like, for example, in that project, we might not want to make it crash because we forgot to declare an if call, but we might want to make it, make the linter tell us in the continuous integration pipeline that, hey, you have a potentially division by zero here or there, you should probably take a look at that because you're gonna cause crashes. And that's a lot more useful. So, and also like the last user experience thing that we added was comment-based check suppression. This works in the same way that Rust does. Like you just, like if you have a particular check that for that particular part of your domain is a non-issue because whatever, maybe your contracts won't ever like, let's go with the division by zero, right? Like, you know for sure that the contracts can't emit a zero value for the parameter that you're using for the division, so it
Mm,
can never be a division by zero, even if
right.
the linter tells you otherwise, because the linter doesn't know about your domain. It only knows that, hey, you're dividing by a parameter that we don't know the value of, and it can be zero, and you're not checking whether it's zero or not. So I
Mm,
will let you know that there's an error. As a linter, that's the only thing that I can do. But you as a developer have a lot more context, and you can say, okay, I know this value can never be zero. So I'm
right.
just gonna, like, I don't want it to crash because of this. So I'm
Yep.
just gonna comment it out. Don't check this line, and that's pretty
Yes.
much it.
The check that rung true with me is when you get a token that's coming through or an event that's essentially malformed data. I've had that crash a subgraph with me a few times,
Yeah.
randomly. Like, you're just going along and just dead. And you're like, what the heck is that? And you have to go and discover, oh my gosh, like it's getting weird data. I love that those little things that you don't know about until it's unfortunately too late. This has an opportunity to catch. And
Yeah.
yeah, you've done a good job of getting the major ones, not just optimizations, but those those errors that will shut a subgraph down if you don't catch those at deploy.
Yeah, for sure. Again, like, these are the whole list of common errors that I've been finding are the ones that we implemented checks for.
Yep.
Checks can be added, like, the repository is public, so anyone can add checks. We
Yeah,
actually
I'll
have a
drop that in
guide
the
on how
chat
to add
here.
checks.
Let me drop that in the chat here for
Yeah.
everyone. Go ahead and check out this. This is live right now.
Yeah, I'm gonna finish with the presentation, which is just this slide. So like, the final thing, like, after the post processing, it just outputs the final result, and that's it.
Mm.
How does the subgraph linter work? It's showtime, folks. Like, that means it's time for a demo.
Yes,
So I don't even know where I'm at currently. I'm just gonna
I
start
can
sharing.
see. Well, yeah,
Yeah,
I now
because
lost.
I shared the presentation, and oh
Got it.
god, like, I'm so used to having two monitors, and having a single one is,
Right.
yeah, it's giving me anxiety right now. But
You're doing great.
yeah, let's see, how can we do that with one. I'm just gonna share my whole screen.
Okay.
That's probably the simplest. Uh, if I can't, there we go. Share screen. It's funny that for developers, the hardest thing to ever do is share your screen, entire screen. So yeah, you're gonna see the matrix now.
Yeah, there we go. Matrix, matrix.
And okay, like, the first thing is, this is how I normally use it. Like, again, this is actually the
And
code. I don't know.
real quick, Juan, just for the sake of viewers here, could you go
Yeah,
ahead and, yeah, there you go, make that
there
screen
we
a
go.
little.
Yeah, I was expecting that. So let's just make this a little bit smaller. This is actually just the code for the linter. I actually made some, like, while I was preparing this presentation, I realized, like, there were some edge cases that were not being properly figured out. So I am in the process of fixing that. But as you can see, in the code, we actually have this. Again, this was a tool that has been mostly built by architecturing it myself, and help coding it with AI, as many folks do now. So we don't use a particular testing framework. We just have some what we call test fixtures, which are just like random mappings that we have here that we know are gonna be problematic patterns, and some random mappings that we know that are not gonna be problematic patterns. And we try to make sure that the negative ones, so the non-problematic ones, are not being flagged, and that the positive ones are all being flagged as they should be. And the way that it works, and again, this is using it as a VS Code extension. You can use it as a CLI. We will go through the CLI just after this, but with VS Code extension, it's a little bit more visual to showcase. So for example, let's go with, these are all warnings. As you can see, VS Code allows you through LSP to actually just give you an error message, give you the line where the error is actually happening, and a bunch of other context. Like, for example, in this case, we have division uses a potentially zero denominator. Most likely this has unsafe ratio. Is 10 over divisor. Divisor is a number, and it can be zero, and we don't check that it's not zero. So it will flag you that, let's go back to here. Here, you're actually doing a potential division by zero. It will not tell you that it is always zero because it can know, but it will know that it's potentially a division by zero. The way that you would fix it is instead of doing this, you would do like if let's do like divisor zero, then let's do like 1 or whatever, like just for the sake of making it quick. And it should, I haven't checked it. Well, I didn't save it. There we go. It should, make it sure that now it's no longer a division by zero, so it's not unsafe. And I have only 9% of battery, so let's do this quickly.
This is exciting here.
This is not a Mac. This explodes in seconds. So yeah, essentially, like if I go back, I will have again this error, and it will tell me the same thing again. This happens for all of the checks. I'm gonna be really brief because I'm gonna run out of battery soon. But essentially, you have all of those will be, as with any LSP, it will allow you to check those in the line where it's happening, and it will also give you the output here in the problems terminal where you can just click and go to whatever place you have a particular thing. Like this is for the ETH calls, yada yada yada. Sure. And for the sake of time, I'm just gonna actually do npm run check fixtures. This is gonna do the same checks for the fixtures. As I mentioned previously, I took a lot of inspiration from Rust, so that is why it looks a little bit like the Rust compiler.
Of course, make it a little bigger too, once again, just for so the viewers.
Oh yeah, let's see if I can actually.
I ran this on a init subgraph, and it came back with no errors. And I was like, oh my gosh, this is great. So I needed to go write some errors and or some warnings as well. So
where was the appearance? There we go. Let's do 20 or something. Hopefully
that should be good enough.
Like
perfect.
Let's see. Okay, that should be probably better. And again, it's the same errors. It will be red if it's an error. If it's a warning, it will be yellow. And it will tell you the same. Like essentially, the metadata is gonna be exactly the same that you get here, like the same error message, everything. And it will tell you exactly in which line it's happening. It
does look designed like the Rust compiler.
It is a little bit inspired, yes.
Yeah.
It's not exactly the same, but I tried to make.
I see it though. I see it with the line and the little arrows and exactly where in the suggestions.
And it will throw a summary of all of the errors and warnings that you have.
Very nice.
You don't have to scroll. So yeah, like this is essentially it. I was gonna go through an example one, but I'm gonna run out of battery soon, and I don't have any electricity now. So
just for the sake of safety of your batteries, amazing, Juan, for putting this together. Thank you so much. If there's a takeaway that you want any engineer who's watching this to take away from this, what would that be in terms of what you have built with Subgraph Linter?
I mean, like the only thing that I can say to every engineer is just try it out. If you have any issues or if you find that it's not flagging something that you should be flagged, just let me know. Write an issue in GitHub. Of course, this is an open source tool, so you can create your own checks. Like there's, I think you, Marcus, already shared the adding checks, or at least the repo. The repo has some adding checks document that will allow you to understand how to add them easily. I've been finding that Codex, Claude, all of those AIs are really good at adding these type of checks. It's essentially kind of like whenever you use it for adding tests. Well, it's mostly the same thing. Everything's really well structured, so you have a tree structure, an AST that the AI will be able to figure out quite quickly how to structure those checks. And again, sky's the limit. You can add as many checks as you want. You can play around with it, find issues. I have no ego with this. Like again, I was gonna call it basic subgraph linter because for me it's only a couple checks. Like I wanted to have all of the checks because I want it to be perfect. I want it to be almost as if it's a Rust compiler that it tells you if I tell you that it's gonna work okay, you can trust me. And I want to get to that point where the tool is as trustworthy as the Rust compiler is for the Rustaceans.
Right. Well, I appreciate your effort, and I know Subgraph developers out there appreciate your effort as well. You heard him. Go ahead and try out Subgraph Linter. I left the links in Discord as well as in chat here. And so, really, just thank you so much for your work, Juan, and thank you so much for your time. And everyone watching, thank you so much for tuning in to Graph Builders Office Hours. And I'll be here next week. We'll be talking a little bit more about AMP and what AMP is doing in the next iteration of its build. So, Juan, thank you for your time. If you could just stay on the line here while I close the stream. Everyone else,
For
have a
sure.
great rest of your Thursday.
Thanks, everyone.